February the 17th, 1869. It may be relevant to the process of discovery that Mendeleev enjoyed playing a form of solitaire called patience, that he had written out the elements in cards, which he dealt into columns and rows. Hi, Year 7. So, today we're going to be looking at what's inside the atom. So, John Dalton told us yesterday that atoms were the smallest thing we could have. And yet today we're going to find out that we can go even smaller and find out what is inside those atoms. Pause. Okay, so two websites that I want to make you aware of for this lesson. The first one, periodicvideos.com. This one's really interesting and tells you about all the different elements. If you've got a bit of time, go there, have a play on it, watch some videos. They're really fun. I will be asking you to watch specific videos of these later in the series. The second one, which is phet.colorado.edu/en/simulation/build-an-atom. This is the one that I'm going to ask you to use today. Okay, it's up to you. You can watch my video, then you can go use it, and you can either send a screenshot or build your own atom creatively at home and send a picture of that to your teacher. Or you can watch my video, see what it's all about, and then go and have a bit of a play. There is a worksheet for you to fill in as well. Just you can figure it out all just using this website, or you can watch this video, fill it out, go have a play, or you can ignore it entirely and just do the website and be creative, because I'm going to cover everything you need. Okay, so I do like my periodic table, and as such have quite a few periodic table mugs. Periodic tables you've got don't show this, but this is John Dalton's original periodic table, and that's what all the symbols meant. That's Dmitri Mendeleev, and this is our fairly modern periodic table, which is similar to the one that you built last lesson. But today we're going to go inside of these atoms. Just thought that might be interesting. So we're going to go inside of the atoms and find out what's in there, because on the periodic table you can see you have got numbers, and you can see this on the one that I sent you last lesson at home. I'll send it again this lesson. You've got two numbers, one of which is smaller than the other. What does all this mean? Well, to know that, we need to know what's inside the atom. So let's take our chocolate bar, let's split it up into tiny bits. Let's split each molecule of chocolate up into its component atoms, and let's take those atoms and let's open them up like they were some sort of a little nut and see what's inside the shell. So atoms we can think of like little balls or little circles. You will possibly be quite disappointed to see that this plate doesn't have a periodic table on. I don't have a periodic table plate. It is a disappointment, I agree. So what's inside the atom? Well, in the middle of the atom, there is something called a nucleus. You may recognise the word nucleus from when you learnt about cells. It's the exact same word. And inside the nucleus, there lives something called a proton. Protons are big, and they have a relative mass of 1. Protons are also positive. Okay, and we remember that with the P's. Protons are positive. Okay, so each proton has a mass of 1 and a charge of +1. But atoms don't have any charge, so if there's a positive, there has to be a negative. And it was discovered that we have little negative electrons that zoom around, that orbit the atom, a little like the way that planets orbit the sun and the other stars as well. So these electrons zoom around. They're attracted to the positivity, but they're moving. They never actually get there. So this is a negative electron. you will notice it is a lot smaller than the proton. Electrons have pretty much no mass. Okay, the only mass comes from the nucleus. Okay, sorry, a little bit of child noise there. So as I was saying, positive proton, mass of 1, charge of +1 in the middle, in the nucleus. Negative electron, no mass, charge of -1, zooming around the outside in what's either known as an orbital, because it's an orbit, or a shell. Both words are correct. Okay, so, and that's what the inside of hydrogen looks like. Okay, hydrogen has number 1 and number 1. That number, doesn't matter which number 1 in this case. The proton number, or the atomic number, tells us the number of protons. So in this case, we know that there is 1 proton. If there is 1 proton, it is balanced out with 1 electron. The second number 1 is the mass number. So that tells us the amount of mass there is in a atom. And because the mass is 1, I know I must have 1 proton, because the mass of a proton is 1. Okay, we're going to go on. This is an element that Mendeleev didn't know about, helium. It was discovered when astronomers were looking at the sun and found a light spectrum they'd never seen before. And they called it helium after the word helios. So it means it comes from the sun. Okay, and there are 2 numbers here. You should have a number 4 at the top there and a 2 at the bottom. You will notice this is slightly different. Okay, so instead of having them at the top and the bottom, you've got them both at the top. Doesn't matter. You need to know the little number is the proton number. So there's 2 protons. If there's 2 protons, how many electrons? 2. Well done. Okay, but there's a mass of 4. Hang on a second. Let's just take a look at our atomic plate again. So here we have in our nucleus 2 protons and 2 negative electrons zooming around. But those positives, they're going to repel each other like 2 north poles of a magnet jammed together. They're not going to be happy. So what? And as well as which, they have a mass of 1 each. 1, 2. That is not a mass of 4. What's going to happen? Enter the 3rd subatomic particle, the neutron. Now, neutrons have a mass of 1. Look, neutrons and protons are the same size. They have the same mass, which is 1. There are no units. You know how we always say in science, always use a unit. You can never use a number on its own, because if you use a number on its own, what are you talking about? We've got a mass of 4. For what? 4 grams? 4 bananas? 4 houses? It doesn't make sense. In this case, it's a relative mass of 4. So we don't need to worry about units just yet. Neutrons are neutral. They have no charge. They're not changing the charge of the atom. But look at this. When you build your nucleus, these positives now can move together because they're not stuck together. They're not repelling each other quite as much. If you go on and do A-level physics, you'll find out there's something called a strong nuclear force holding them together, but that's not a force you have to worry about yet. So here we go. This is helium. 2 electrons on the small orbital or shell close to the nucleus, and a nucleus with 1, 2, 3, 4, a mass of 4, with 1, 2 protons and 1, 2 of these new things, these neutral neutrons. Okay, so we're going to want it to get a bit bigger. So let's look at the next atom. Here we've got lithium. Lithium has got a mass of 7 and 3 of them are protons. Okay, so let's add another proton into the mix. 1, 2, 3 protons. 3 protons means I need 3 electrons. Okay, my charge is fine now. 3 positive protons, 3 negative electrons. But wait, I have a mass of 7. Okay, lithium mass number 7. How am I going to make 3 protons with a mass of 3 into a mass of 7? Hey, you're getting this. You add neutrons. Well done. How many neutrons? How many neutrons do I need to make it up to 7? Okay, so I've got 3 protons. I need to make 7. The difference between 7 and 3 is 4. So I need to add 4 neutrons. So let's do that. Okay. 1, 2, 3. Okay, so there we go. My nucleus is getting bigger. It's got 3 positive protons and 4 neutral neutrons. And those 3 positive protons are balanced out by 3 negative electrons, which have no mass. Okay, so remember, all the mass is in the nucleus. The atom is mostly empty space with teeny tiny, next to no mass at all, electrons zooming around in orbits. Okay, the charge, the nucleus is positive. The nucleus is positive, but all of these electrons zooming around, these teeny tiny no mass electrons, are negative. Okay, 1 positive proton, 1 negative electron. Okay, you don't get an electron that's 2 negative or 3 negative. Electrons are always 1 negative. Same for protons. 3 positive protons means you have 3 protons, each of which have 1 positive. Okay? If you're getting your head around this, really well done. So, we're going to skip on a bit. We are going to build carbon because that's one of the important elements. If you go on, you will learn that there's 2 sides to chemistry. There's organic and inorganic, and organic chemistry is all about what carbon does, because carbon is so important for life. So we're going to build an atom of carbon. You can pause the video and have a go yourself, okay? So carbon, we find out, has a mass of 12 and a proton number of 6. Okay, so atomic number 6, proton number 6. How many protons do we need? 6. So let's get ourselves 6 protons. Okay, so here we go. 6 positive protons. And that means we are also going to need 6 negative electrons. You'll notice that I'm spacing them out a bit. So you've got 2 on the sort of inner ring and 4 on the outer ring. That's because the inner ring fits 2 electrons, the outer ring will fit up to 8. Don't worry about that. You'll do more on that later. Okay, I just don't like to do it incorrectly now, because then you have to unlearn something when you come to doing this in year 9. So we've got 6 positive protons and 6 negative electrons. Our negative electrons have no mass. Protons have a mass of 1 each. But our mass of carbon was 12. So we're going to need to add in some neutral neutrons. How many neutrons do you think we're going to have to add? Hey, nice one, 6. You're getting the hang of this. So, 6 neutrons. And what I'm going to do is I'm going to ask you, my darling, can you build this nucleus for me? Yeah, should we put it all together? Okay, so let's go. Let's build it up. Yeah? Can you put some on? Where are you going to put that proton? It can go there. Good call. And let's put a neutron there. And you're going to put your neutron on here? Where do you want to put it? Oh, proton here. And where's the last neutron going? There. Excellent. So here we go. We've got a little roundish nucleus. Goes in the middle with our electrons flying all around. Oh, that is a good question. I can hear it through the internet. Well done. You're right, if the nucleus is 3D, why are the electrons zooming around in 2D circles? That's a great question. The answer is they don't, but it's a bit hard for me to model a three-dimensional electrons zooming around. So when we model it and when we draw it, we always do it as two-dimensional. Let's see what this looks like to draw. Okay, so when we draw it, okay, so I've got a nucleus here with 6 protons and 6 neutrons in. Now, just in case that isn't obvious, what I have here is I've labelled it nucleus, 6 protons, 6 neutrons. 6 plus 6 is 12, so it has a mass of 12. So carbon, mass 12, proton number 6, sorted. And then we're going to draw circles around the outside. These are our shells or orbitals, and we're going to put on little E's. Okay, and then we can write down 6 electrons in, sorry, I'm writing this upside down, so it's a little bit harder, in shells. Okay, so that we can see we've got 6 electrons, negative electrons, to balance out our positive protons, zooming around the outside of that atom. So what I'd like you to do is there's a little worksheet to do, really quick. There is an optional worksheet to do if you really like calculating the numbers of protons and neutrons. You don't have to do that. But the other thing I'd like you to do is to make a model of an atom of your choice. Now, I've done carbon, and I've done it as a picture, and I've also done it as a model here. Okay, so you could make a model like this, or you could do it with cake, or you could actually make one where the electrons were a bit more 3D, and you can take a picture of that. You don't have to, you can do a nice little drawing like I've done. One thing to do, if you want to do an atom that is in the 3rd period or the 4th period, you're going to get loads of electrons. I would suggest you don't go past calcium. But you've got 2 electrons in the first shell, 8 electrons in the second, 8 electrons in the third, and 18 in the fourth. But you don't have to do a complicated one, you can just do carbon. Okay, it works really well if you use stickers as well, but up to you how you want to do it. Okay, so that's the end of today's little lesson. Hope you've enjoyed it. Off you go. There's a little bit of work for you to do, as I've said. Enjoy it. Let your teachers know how you're getting on. If you do have any questions, please ask, and I will see you for another lesson very soon. Bye.